So with the secondary circulation, what we're doing is we're tracking the movement of our high and low pressure cells across the surface of the globe, moving northward, moving southward, and then moving based on the direction of the winds, the westerlies and the easterlies, and of course those trade winds as well. So we're moving across the planet and pushing these high and low pressure cells around as a result. For the next few slides, so much of this is redundant. It just happens to be the order that the textbook provides it in. But again, redundancy is good because it gives us the opportunity to review. So what ends up happening is we get these location of these high and low pressure cells are related to seasonal variation in the changing amounts of sunlight at particular locations during the year. So we're going to migrate these cells north and south. So here I've got a scenario of July. And in July, the intertropical convergence zone is on the northern hemisphere side. So it's sitting up in here. So that means the lift is going to happen a little bit higher. The low pressure cell is showing here right at the equator, but part of that is the need to remember that a lot of energy is coming in and it's being absorbed by the Pacific Ocean. And so we're not giving off a lot of energy back and radiating it back into the atmosphere. So this low is not going to move a whole lot. But where I want you to pay attention to lows and highs is that I've got this low right here, right around the Sahel in Africa. This low has moved quite high into like Kazakhstan, Uzbekistan, up through here. It's just here's India, and the Hindu Kush is through here. So I've got this very large low pressure cell, which is shown by this great big kidney shape. And then we've got some warm water here between the Indian Oceans and the Pacific Ocean. So this low is a little bit lower. So I've got that. I've got two other lows I want you to pay attention to. I've got the genesis, or the creation of a low, here in the desert area of North America. And then I'm generating a low right here at 60 degrees off of Quebec and Baffin Island, right? Look at what's happening here at these same latitudes. Now, Asia is enormous. The bigger the land mass in the summertime, the bigger the low pressure cell is going to be, because we've got more mass to radiate energy off of. So this is going to be a large low pressure cell that's generated here, just because this is our largest continental mass through here between Asia and Europe. All right. In the southern hemisphere, these highs that were sitting at 30 are being pulled like a slinky towards the equator. So if the sun is pushing in this direction, it's compressing and pushing these high and lows northward, but it's dragging all of the ones in the southern hemisphere and expanding these cells towards the equator here. So our highs that are sitting around 30, and we're sitting with a lot of ocean here. The one thing that the maps don't give us a chance to appreciate is in the northern hemisphere we have a lot of land mass, and we often call that the terrestrial hemisphere. And in the southern hemisphere, it's mostly ocean. So it's the water hemisphere, or the ocean hemisphere. And so the ocean hemisphere is going to store and release energy much more slowly than the northern hemisphere is going to. So we're not going to see as much variability and change in the southern hemisphere as the northern hemisphere, because that beautiful water molecule is just going to take its time, and it's going to do its thing, and it's going to moderate the rate of change and produce very little change. So that's July. So in January, we know the sun is in the southern hemisphere, and we take a look, and what has happened is we've lost this big, enormous low pressure cell here, and we've replaced it with a big high pressure cell. So in the northern hemisphere, with this large land mass, remember that when we have land, we don't have storage capacity for energy. So we're radiating all that energy off and warming the atmosphere and creating a low pressure cell over Asia. In Asia in the wintertime, doesn't matter how much sun is shining, there's just not enough energy to warm up the surface of the earth, so it's going to be cool. So we're going to have this ginormous low pressure cell sitting over Asia as a result. A little bit of a low pressure cell sitting over the Mediterranean, because now the Mediterranean has now releasing the energy that it had stored up in the summertime. So we've got a little pocket of low. The high pressure cell sitting across the Atlantic is because we have lost energy off of these two large land masses, which are squashing the Pacific, or pardon me, the Atlantic Ocean. So that energy is sort of being lost. There's not enough large volume of energy to really warm up that atmosphere. So it's a high pressure cells there. And these highs are pushing southwards. So because the sun is in the southern hemisphere, so we're going to generate a low pressure cell over South America. We did not have one here, but now we are in the southern hemisphere, and this is a land mass, so we can generate a low here. We're going to replace the high pressure cell that was sitting here somewhat over the Congo with this low. So this low moved southward and is now sort of Central Africa. And then the lows that were sitting right in here have, like that slinky being pulled across, now move further south and are starting to hit the northern part of Australia. And we're moving across places like Fiji and Toga and Sumatra. All these areas now are under a low pressure cell. The high pressure cell now, where it was cold, was one large landmass, now has broken up a little bit, because now that sunlight is warming up this surface area here, and there's a little bit of energy being given off. Band of pressure cell here, which is that high pressure cell at 60 degrees. So large high pressure cell here, and the large high pressure cell here has not moved seasonally very much. So take note of that. And then the retention of the high pressure cell sitting here in Antarctica has changed a little bit, but moderately, not a whole lot. So this is our secondary circulation. It's just the migration north and south across the equator and across the northern hemisphere and the southern hemisphere with these pressure cells. Now, I make the statement that these pressure cells are always closed. So you can see this is a complete loop. It's a complete loop. It's a complete loop. If we were to take a look and make this global, we'll see that this comes across right where it lets off here. It's picking up here. All right. So this is all one big mass that's all connected. It's like a big blob. All right. So we're not getting anything trailing off anywhere. So that's important to recognize. I'm going to give you one more slide here, and then we'll, pardon me, yeah, one more slide here, and then we'll call this a done set. So I like this slide set because it gives you the isolines, and it gives you the recognition of how, when these cells move, what it does to the wind conditions. So unfortunately, I've got January and February flipped from the slide before. So we'll start with July, because we started with July the last time. It was the top figure in the last slide. So the sun is in the northern hemisphere in July. The intertropical convergence zone, as delineated by this red dotted line, shows you the warmest portion of the earth, or where the most energy is. We've pushed this high up here. It's sort of parallel with sort of Oregon, for instance, and then this high is parallel with Spain, and it's quite large in size, because at this point, remember, water is absorbing energy, so it's cooler, and the land is radiating energy, so it's warmer. So there, we could actually have a very weak low pressure cell here, and I see that low is right here, right over where I said it was before, which is our desert area in North America: Arizona, Utah, Texas, and Arizona. All right, so this is where that low is sitting. So we've got a low there. We've got a low sitting over here, Here's India. So here's the Kazakhstan, Uzbekistan, Iran, Iraq, sitting right over here as well. All right. So just real quick, because I did this in the former slide, take a look and see what happens when we move into January, when the sun is in the southern hemisphere. That ITCZ moves. And so what I really want you to see is how much some of these features have moved. So where the ITC was on the northern part of the Brazilian rainforest, now the ITC is stretching down to the southern extent of that rainforest. Where the ITCZ was crossing the Sahara Desert, now it's come way down low and it's down around near Zimbabwe. So we've got that. It was bifurcating and stretching across between Nepal and China in July, and then in January it's cutting across the Indian Ocean and it's starting to clip into Australia. So that's how much that's moved. Let's just take a look at where this high was. So this high sitting across from sort of San Diego area now in July is sitting a little farther north. It's sort of northern California, northern Oregon. So we've pushed that high basically the whole length of the California state. In January, we've got a low pressure cell which is generated, but we don't have that low pressure cell in July. There's just not enough movement, and that low is sort of sitting way up here as a result. You can do the same exercise, see where these highs and lows sit relative to where they are in the southern hemisphere in July and in January. But what I really want you to pay attention to is what happens to these ISO lines. Look how close they are in January through here. So these are some of the fastest winds on the planet, exceptionally fast through here, particularly around South America here as we squash between Patagonia and McMurdo. Some of the wildest winds and most dangerous waters are through here. So before we had the Panama Canal and all of that freight had to come through here, not only did it take a lot of time and take a lot of energy, but it was exceptionally dangerous to move goods and people between these two oceans. So the Panama Canal was really imperative to get constructed. In July, because we entered, or we've sort of moved the slinky to the northern hemisphere, all the slinky coils are pulling towards the north. So we're opening this up, and as we open this up, the winds start to diminish. So ideally and ironically, during the time of travel to get goods back and forth between the two oceans, the best time to travel was when it was winter in the southern hemisphere, because the wind velocities were at their weakest at this juncture right here, this little bottleneck that was created. All right, guys, on to the next set in a second.